Okay, let's talk about another topic, filter. Okay, so we already talked about that, but in the lab. But let's just talk about more in terms of its theory and its transfer functions. First of all, when we talk about filter, there are two types of filters. We said it's a passive filter and active filter. So passive filter, that's what we have in the first circuitry lab, like RCL components. And then active filter, particularly we incorporate op-amp in the component, which is typical integrated circuit chip, semiconductor base. Okay, so what's the difference between these two? There are major difference is that the passive filters, like we have in the lab, the gain is only have one. Only one. In other words, it's not capable for amplification. However, the op-amp filter, active filter, is capable of amplifications. Capable amplifications. So that's one of the advantage of using the active filters. The other one, you might notice when we have these filter lab for our measurement class lab, we don't use inductor. In other words, this one, no inductor needed. Particular for bandpass filter or band notch filter, cut filters. Okay, so let's talk about what is op-amp. So, which is what we call operational amplifier. Okay, it's basically a bunch of, it's an integrated circuit. An integrated circuit, and consists of a bunch of transistor, resistors, and capacitors. So this one gives you just a illustration of this real 741 type of operational amplifier. So this is a circuitry. So there are several resistors, capacitors, and terminal totally combined. We treat it as a over one integrated circuit. So, so we use a symbol to represent this type of op-amp operational amplifiers. This triangle, and we have the voltage output and two input terminal. And we say this is negative, positive. The symbol represents negative part, saying this is inverting. and this is non-inverting for positive part. Okay, and we use this as symbols. And for the ideal case, and we can treat this or model this for the equivalent op-amp circuit, meaning that so this is, in other words, the operational amplifier need to be powered. We put this is VCC positive, VCC negative. This is V out. So we say this is our input impedance, VRI or RO. So we said for this one, for ideal op-amp, you will have infinite net input impedance, which is Ri, and zero output impedance. Normally we use RO or ZIGO. And the gain, open loop gain, is infinite. So what does this mean? Meaning that we treat this circuit as a relationship. This is we say this one here is E negative, this point E positive, V out. So you should have the relationship for the gain should be V out equal to G times E positive minus E negative. So this G for open loop gain will be infinite. However, there's a characteristic of this op-amp is that you already have it in the lab, is this G is infinite, but sorry, V out okay. So this, even though it's infinite for ideal case, however, if you really look at the characteristic, this will have this G. If you plot E positive minus E negative in x-axis, this is V out in y-axis. The slope is G. However, this one will reach to a point and then 1, 2, 3, 4, 1, 2, 3, 4. Then stopped. We call this saturations. In other words, this is values is limited to the supplied powers support to activate the up band, which is VCC negative, VCC positive. Okay. If you remember in the lab, we have around 15 volt VDC. But when you have gain of 20, more than or input 2, output is gain of 10 should be 20. However, you will not reach 20 volt. You get around 13 or 14 volt because of this saturation effect. Okay, so also for the typical 741 series up band, if you look at this pin out, you should have a pin for this chip. Okay, so we should have this one. So normally we only use this 3, that's the out. This is negative positive, so E negative, E positive terminal, and also 2 voltage supplies, VCC positive, negative. Okay. So the other 3 terminal we don't use. This is called NC, not connected, or this is for trim for to do the offset. But in general, we only use 1, 2, 3, 4, 5 pin to make a circuit. So this is for up band characteristics, and also again for ideal case we have infinite to model this. We say we have infinite. We say we have infinite input impedance and 0 output impedance, which this one will reduce our loading effect or alleviate loading effect. But in real case, it's not exact like this. That's why, but when we analyze this, we treat it as an ideal case. So this one, this up band, well, is seldom used. Open loop. Mode. Always are used. In a feedback loop. Closed loop feedback mode. Okay, so next question is how do we model or analyzing up band circuit. we based on two principles other than voltage, Kirchhoff voltage and the current law, loop law and node law. Also have two principles. One is the voltage difference between two input terminal is 0. Two input terminal, meaning these two, or two input terminal. In other words, two input terminal, V negative, V positive. So voltage difference between these two, when it's in a closed loop mode, these two will be balanced and would be, there's no difference between these two. In other words, difference equal to 0. In other words, E positive is always equal to E negative. But it doesn't need to be 0, just equal. If one of this terminal is connected to ground, and then it's 0. But this is always true. Equal to 0, not necessarily, depends on the circuit. Okay, and the other one will be the current flowed into two input terminal. Is 0. So you assume you model the big circuit, integrated circuit, as this simple circuit. The current flow into these terminals. So the current here from E negative to E positive, vice versa, should be, let's say it's IA. This IA should be 0. Or will be the same. This IA should be 0. So will be the same argument, same statement, because if these two terminals have 0 difference, meaning they are the same. If they are the same, of course, same voltage potential. Of course, there's no current flow through these two. Okay. So we use these two principles in addition to voltage, Kirchhoff voltage law and Kirchhoff current law. We can solve these circuit, up-band circuit.